Okay, here's an RL circuit to to maybe give you some fear. And the reason is that we're going to ask for the time constant on this circuit, not when it was discharging. So when the switch is open, the time constant would be fairly straightforward, just in terms of R and L here, because it would just be a simple RL circuit. When it's closed, it's a lot more complicated because we have this other resistor involved here. And so to solve this, we're really going to have to write out the Kirchhoff's voltage rules and current rules for this circuit, and then go ahead and make it look like a standard RL circuit and read off the coefficients. So don't get frightened by this. We'll just go through it. You'll see it's not so bad. So the first thing is we're going to do a loop, and let me just draw it. I'm just going to go around inside here. So we can see my terms, my voltage across my inductor, voltage across the bottom resistor, and then the voltage across the battery there. And I'll do a second circuit. In that case here, I'm going to go around this way on the right side loop, loop number 2. Again, the voltage across the inductor here, and the voltage across the resistor, I've written it in terms of sort of using Kirchhoff's current rule already. So let's set up. Sorry for the background noise here. Office is a little loud today. Okay, so I'm going to rewrite the equation 1 from loop 1. I'm going to solve it for I times R so I can substitute it into equation 2. So doing that, by rearranging things, V becomes positive, L di dt became negative, and now I'm going to take and I'm going to substitute that in for my I times R term right here, so that everything is in terms of I1, the current through the inductor. And if I go ahead and do that, I get several terms here. I would get a couple terms with L di dt, and then I have my voltage across the battery and my voltage across the resistor. So I can simplify that so it looks like a simple LR circuit. Notice my coefficient here is 2L in front of the di dt, and then my I times R. So this 2L is going to be the effective inductance for my time constant here. And so my time constant, which is just L over R, well, it's really the coefficient of the di dt, so it's 2L over R. And so there's the answer to that one.